let's do the review number 3 for your exam number 3, right? Which covers chapter 9 and sections 10.1 through 10.3. So chapter 9, we studied what? All the crazy numbers, right? Radicals. The basic skills, add, subtract, multiply, and divide, right? Then we solve the equations, radical equations. And for your sections 10.1 through 10.3, we summarize all the things we have learned in this class for solving quadratic equations, right? Then we have 4 methods, which was by factoring, by using square root properties, by the completing the squares and quadratic formulas, right? Okay, let's see. Then let's do some crazy numbers again, which are radicals. So radicals look like what? You take that's radical symbols, then you take how many roots, right? The number is inside. For even roots, then you need to have a positive number, right? So then how do we know B is the answer for this? That is what? B is the nth root of A. That means what? If B take nth power, it should go back to the number, right? So n is an integer for that. So if we say if B is this, then you have to have this condition, right? That means if 2 is square root of 4, that means what? When you take a 2 squared, then it will be the inside. And if 2 is cube root of 8, that means what? 2 to the 3rd power is 8, right? We did this. Then 2 is 4th power of what? 16, because if 2 take 4th power, it will end up in 16. So that's how we decide that's the root of the radical, right? Then we also have a product rule and quotient rule. Product rule means what? If you have a same index, take the same rule, then you can combine them. Somehow you get confused with the crazy numbers when they are multiplied. Okay, you need to multiply inside if they have same index. Then you simplify this. Okay, so if same index, then you multiply inside, right? Same thing if you have 2 things multiplied together with index, you can split them. That's called product rule. Okay, when you do the simplification, when we ask you to multiply things, you need to put the inside together, right? Then you simplify them. Okay, then same thing for the quotient rule. It means what? You can put them together, same thing. Let's do the same way as the multiplication. If you have 2 things, divide, same index, then you can put them together, or if they are together, you can separate them. Okay? Then provided all those things we are talking about, all those are real numbers. If it's not real numbers, we operate a little bit differently, okay? So that's how we use this for the purpose of what? Add, subtract, and multiply, and divide, and simplify. Okay, we need to use all those rules to do that. And another thing, when you simplify, so multiply, divide, and adding, subtracting, you are okay with all the crazy numbers. Your problem on this section will be your simplification for the radicals. So remember, when you want to simplify, this one has what? Is the simplest form. It means what? The inside of the radicals have to be as simple as possible. No negative, no fractions. Okay? So what we wanted to do is no negative inside the radicals. Okay? Then we say no fraction inside the radicals. Right? Then another thing is as simple as possible. That means if it's a root of the square root of cube, you have to take out. You cannot stay inside because that's a root. You have to show outside. So there is no roots inside the radical either. Okay? Also, another thing we don't want to have is what? We don't want to have no radicals, okay, in the denominator. Because we don't mingle the radicals and fractions. We want to make both are as simple as possible. Okay, as fractions, you always simplify it. Same thing as the radicals. They both have restrictions, right? For the fractions, you cannot have 0 in the denominators. And for radicals, and you cannot have a negative number for the even radicals, right? So those are restrictions. Okay, sometimes we write what? We say for a radical, it can be written as the power form. They are the same. Okay, if it's a power form, then the power doesn't mean real numbers for the fraction. The top one means what? The power, regular, right? The bottom one means the what? The roots. Okay, so it means what? It can be written the power and the root, or you can do what? The root first, then do the power. They end up the same thing. All right, so we went through all the definitions and the behaviors of the crazy numbers, right? And let's review some rational exponents. rational means a fraction, right? Ratio. So then we apply those concepts for a number. So if you have -8 to the -2/3, right? This -8 means real -8, 8 with a negative number. But for the power, negative doesn't mean negative. It means what? Reciprocal, right? So it should be reciprocal of this becomes what? In a denominator, but your -8 is a real number, -8. Then you do that, right? And it means what? -8, take a cube, then take a square, right? Then -8 take a cube is -2, -2 take a square, that would be what? 1/4, right? So the negative exponent, what does that mean? It means, for this guy, right? It means the reciprocal of the positive exponent, right? Just like that. Okay, reciprocal of positive. When you do the reciprocal, you have to change it become positive exponent, right? And another terminologies we have used, okay, on your page 2. What does it mean to rationalize a denominator? Rationalize means what? Make it irrational. Then make it irrational means what? It's like a ratio, and make it fraction styles. But when we have a fractional styles, we cannot have radicals in a denominator. Okay? So it's like, right? When you do the division, on the bottom you have this one. This one, 4 minus 3 square root 2 to 3 plus square root 2. Then rationalize means make a rational without crazy numbers. Okay? No radicals in a denominator either. That means what? We don't want to have radicals in the denominator. Okay? So it means to what? Eliminate the radicals in the denominator. Okay, so like this one, you have radicals in the denominator, then we say we rationalize it, get rid of the radicals in the denominator. Okay, so how do we do that? We use the conjugate. For the denominator. So like this one, what is its conjugate? Its conjugate would be what? The different sign. Positive will become negative, right? And negative will become positive. That's how we do it. Okay? When you have more than one thing in a denominator, you will use its conjugate to rationalize. Okay, so if you look at the next example, we have two things. One is what? You have one term in the denominator, right? Another one, you have two terms in the denominator. So if you have two terms, to get rid of the radical in the denominators, then you need to use the conjugate. But if it's only one term in the denominator, to rationalize it, to get rid of the radical in the denominator, it's easier to do, right? What do? You just multiply its what? Twin. That's all you need to do, right? Because you have twin, you have a root of square. You have square now instead of the, right, single one. So root of square, it's itself. And somehow you get confused on the top when you multiply. So we said if you have same radical, same index, what do? You put them together. Use the product rule, right? So you have 3 here is what? 35 times 6, right? Then what do? We split, we check. We need to simplify this. Then we see there's no negative, but we do have what? Roots inside. So we wanted to do what? Separate them, see we can do something. 5 and 7 and 2 and 3. Do we have a square root? No, we don't, right? So we just keep as is. Then we simplify this, so that would be 6 times 35, 210. So that's how we rationalize the radicals. That means when we divide radicals, when we have radicals in the denominator, that's how we eliminated the radicals in the denominator, right? If it's a single, you multiply its twin, it'd be okay. But if we have two things in the denominator, binomial, then to rationalize, get rid of it, the radicals, we have to multiply its conjugate, right? Then if you multiply on the bottom, you have to multiply on the top, right? Then see if we actually eliminate the denominators radicals, right? So we check. Then let's see what will happen, right? You do your FOIL, then 3 times 3 minus what? 3 squared root 2. Then on bottom rainbow, you plus square root 2 and minus what? Square root 2 times square root 2. Don't give me square root 2. Often you do that. Okay, so square root 2 times square root 2 is what? Square root of 4, then which is what? 2, right? The middle parts cancel out because 1 is positive, 1 is minus and negative. So 9 minus 2 is what? 7. So the denominator is 7. So we eliminate the radicals in the denominator, right? So we rationalized. Then on the top, let's see, we do our FOIL. Then 4 times 3, 12. 4 times negative 2 minus 4 squared root 2, right? Then this one minus 9 square root 2. Don't mingle your radicals with the numbers because that's like an x. 3x times 3, 9x. So 9 square root 2, right? Then minus 3 square root 2 times square root 2. Often you mix them up. You mess them up as well. Okay, so square root 2 times square root 2 is what? 2, right? So what do we have? Oh, negative times negative is positive, right? So 12 times minus 13 square root 2. 3 times 2 is what? 6. So we should have 18 minus 13 square root 2, right? So we should have 18 minus 13 square root 2, right? So that would be your answer. Simplify the form. Simplest you can get, right? Then we call them what? rationalize the denominator. That means we are doing the division for the radicals, and we have radicals in the denominator. Okay? Then we rationalize it. We said also when we do add subtract, then we are going to combine like terms. That means what? We are going to combine like radicals. Then what are like radicals? That means what? The radicals, they are radicals, okay, with the same index and same inside, right? So inside we'll call them radical. So let's take a look. Is this square root of 3, and are they like radicals? Yes, right? If we have this 1, 5, are they like radicals? No, because they have different indexes, right? So we can only combine those are the same. If they are not the same, we cannot combine them. Okay? So next one, let's just skip, because for imaginary numbers, we are no longer covering in this class. Okay, in your pre-cal and calculus, you might still use those. Okay, so that would be your radicals part. Then we do some simplifying, add, subtract, multiply, divide later, and solve radical equations. And we also do the quadratic equations, solving quadratic equations, right? Then for methods, we have learned first one, the simple one, by factoring, right? Next one, by what? The square root property. We did that. And third one would be what? By completing the square. Right? The last one is what? By the quadratic formula. Then we know quadratic formula will always work, right? Okay, then when we inside the quadratic formula, remember what is your quadratic formula? For solving quadratic equation in standard form, so standard form is what? Ax squared plus bx plus c equals 0, right? Then, by quadratic formula, x can be what? Negative b plus or minus what? B squared minus 4ac all over 2a, right? So you can just plug in. So you might have what? One solution, that's a real one, right? Then you might have what? Two solutions, two real one. Okay, then third one is what? No real solution. Then or doesn't exist, right? We have three conditions. Then you can plug in, actually solve it. But we also said what will happen? You can just use the inside to decide, because if it's a 0, you don't have this, you have one solution. If positive, you have plus or minus, you have two solutions. If it's a negative, it doesn't exist, you don't have a solution, right? So inside of the formula for this, we call them what? Discriminant. So we say, what is a discriminant? You will say 4ac of this one, right? for the standard form of the quadratic equation, then that's the discriminant, right? We can use, okay, it can be used to determine how many solutions they are, right? And what type, how many and what type of the solutions, right? So if b squared minus 4ac equals 0, how many solutions we have? 0. We have one real solution, right? If this one greater than 0, we have what? 2 real solutions, right? And if this one less than 0, we have what? No real solutions. So that's the discriminant, how we are going to use it. Let's practice some problems. Okay, we say simplify this. So for the crazy numbers, so can I have negative inside the radicals? Yes, if it's odd roots, right? So negative 64, take a cube root, it's a negative 4. Or you can take a negative out, right? Then 64 cube root would be what? 4. So you use what? The quotient properties, or the root, you can just split it, right? So m27 to the third, how many times? 3 times become 27. Yeah. Okay, for 9. Then 125 will be 5. So that will be your answer, right? So we simplify that as such. Or you can combine them, but the combine them will not help you, right? Because you want to do it individually. 125 is a good number. So we also solve what? Radical equations, right? So like this, do we have equation? Then do we have a radical there? Yes, so we call them radical equations. Then if we want to solve it, and we have to get m by itself without the crazy symbol there, right? So what do we need to do? Do the opposite. For the square root, we take a square. Then we do both sides. And this one take a square, those cancel out, right? Time twice, so that's your root. Then this one, don't give me this. Don't do that, right? When you take a square, you should do what? FOIL. So that will be m squared minus 8m plus 16, right? Then we solve it, write it in standard form. Right? So what do we have? M squared minus 9m. Okay? Then somehow you get stuck here. This is a binomial, right? Then you don't have a formulas to follow. Trinomial, you can do AC method. But remember, you should do what? First, always, GCF. You will forget. Write the notes for yourself, right? Take m out. So m minus 9 equals 0. So by 0 product property. So you have two parts, right? Don't forget this part. M itself is a variable. It can be 0, or this one minus 9 equals 0. So that would be what? M equals 9. Then we need to circle the answer. Can I circle M? Can I circle 9? Remember, for two things you always need to check. One is radical equations, one is fraction, right? So you plug in. So this one you check is 0 plus 16 equals what? 0 minus 4. This one is 4, this one is -4. They are not the same, right? So we cannot circle that. That's the extraneous, extra one, right? How about this one? Without work, you have to plug in original. Remember that. Okay, don't plug in anything in between. So that would be checking 9 minus 4. That's 25, 5, 5, right? So this one works. So you can circle that, right? Remember, write yourself a note when you do the radicals. Make sure all the considerations are there, right? So we were solving what? Radical equations. Then for this one, not in standard form, but it is a quadratic equation. But which way is the easiest way? When one side is a square, one side is a number, we say what? You can just use square root property, right? Because that's a square. Then if you take a root, square root, then those will cancel out, right? So you take a square root. However, you will always forget about something when you do the square root property. Okay? You will have a plus minus sign there. Doesn't matter how big I write for you, you will forget. Okay? Don't do that. And so what do we have? 3m plus 6 equals plus or minus 72, right? Then when you look the radical inside is a big number, it means what? You might need to simplify. So that would be what? 2 times 2 times 2, that's 8. 8 times 9, that's 3, right? So you have 2 and 3 are roots. You take outside, that will be plus minus 2 times 3 is 6 square root of 2, right? Then that means what? You can write it directly, but somehow some of you will get confused with plus and minus signs. Then you write it separately. Okay? So what do you have? 3m equals what? Negative 6 plus 6 square root of 2. And 3m equal negative 6 minus 6 square root of 2, right? Then to get the m by itself, you divide it by 3 for everyone. So what do you have? M equals negative 2 plus 2 square root of 2, or m equals negative 2 minus square root of 2, right? When you have radicals answered, they are conjugate to each other always. Okay? Or you write the answer together, becomes what? Negative 2 plus minus 2 square root of 2. Right? Okay. Then you can use factoring, you know how. Then that's you. This one use what? Square root property. Then we also practice what? Completing the square. Okay, let's do it again. For completing the square, first we have to make the square complete square, right? Then number is on another side. So let's take the number away. So what do we have? Minus 12r equals negative 6. Right. Then it's better if the leading coefficient is 1, instead of it's complicated at the end, right? So you can do it at the beginning. We say make the leading coefficient is 1. What do we have? 6r equals negative 36, right? Then how do we complete the square? So you have to make a square that's r, right? Then what's the number? Half of a b. Half of b is minus 3, right? You need 2 terms to decide which number you can use. And you need to do the third term to complete it. So that will, when you FOIL, you will minus plus 9, right? Do one side, you do another. So you have a completed square on one side. This one is a negative 25, right? Then, if we solve it, we take square root, then inside is negative. You cannot do that because anything to the square cannot be negative number. So you say what? Doesn't exist. Because anything to the square cannot be a negative number, right? Okay? All right, next one, if you have r squared plus 8r plus 10 equals 15. So we want you to practice more on completing a square. Okay? So first, we move the number to another side, right? Right? Then we want to make it a complete square. Leading coefficient is 1, that's good. Then which number we need to use? Half of a b, that would be 4, right? Then to complete the square, then we need to have a third term by FOIL. This would be what? 16, right? Then you add a 16. You do one side, you do another side. Then this side becomes what? 21, right? So we have a complete square. To isolate your r, you have to take a square root, right? Which is fine. Then when you use square root property, you need to do what? An extra step. Remember this, okay? Then those cancel. So what do we have? Plus minus, right? Then get r by itself. So you're minus 4. So r is what? Negative 4 plus minus square root 21. That's the simplest form. So that would be your answer, right? Are we good? Okay, on your page 4, one more thing we are going to practice, okay? It says solve it by quadratic formula. Okay, let's practice some quadratic formula. First, you have to write it in standard form to use ABC, right? So 5a squared plus 3a minus 2 on each side, right? So your a is 5, b is 3, c is what? Negative 2. Then you plug in, so your x actually is what? A is x, right? So your a actually is x. Formula says what? Negative b plus minus what? B squared minus 4ac discriminant inside over 2a, right? So we solve it. For variable a, you plug in negative b is what? Negative 3 plus or minus b squared. 3 squared minus 4a is what? 5, c is negative 2, right? Over 2a, a is what? 5. then you plug in. That would be -3 plus minus 3 squared is 9, 20, 40, plus 40, right? So it would be plus 3 squared, 49, okay, equals 10. Then what's your answer? That would be square root of 9. You know it's good, so it's 7, right? But don't leave the answer there, because a bunch of numbers for fractions, you need to simplify. And when you simplify, you need to write it individually. Don't just do it randomly, okay? Write it out, then simplify it. -3 plus 7 would be what? So our answer would be this. That would be 4 over 10. Don't leave there, right? Either you need to what? Simplify. Becomes what? 2/5, right? Then for this one, -3 minus -7 is what? -10 over 10, which would be what? -1. Is that right? Okay. Let's do one more. X squared plus 25 equals 6x. Then we use what? Quadratic formula, right? So then write it in standard form first. Minus 6x on both sides, right? So A is 1, B is -6, C is 25, right? So your x is what? -b, negative. So -6, right? Plus, minus, negative. So b squared. B is -6. Put a parenthesis around, right? Minus 4ac. A is 1, C is 25, right? O over 2a. A is 1. So what do we have? Here is 6 plus minus 36 minus 100 is what? -64 over 2, right? But for the even root, can we use negative inside? Not in this class, right? So what's your answer? No real solution or doesn't exist. Either way is fine. Okay? That's how we use the quadratic equation, quadratic formulas, to solve those. All right. Are we good? That will be on your test exam 3.